Dear students, today we are going to study about the next accelerator, that is Betatron. So as the name suggests, Betatron is an accelerator which is used to accelerate electrons. Now why the name Betatron? Because when a nucleus decays and alpha, beta or gamma some kind of radiation is emitted, उसमें जो beta radiation emit होती है, particles emit होते हैं, तो they are basically electrons. So this device is used to accelerate high energy electrons, and the maximum kinetic energy which can we gain with the help of this accelerator is about 300 mega electron volts, so very high energy. And now what's the basic principle of Betatron which can be used to accelerate electrons? So there are two types of fields here. One is the magnetic guide field, and this magnetic guide field is basically, its aim is to keep the electrons in a circular path. So जो उसका path set करना है कि एक fixed this part is different from that of cyclotron. In cyclotron जो इलेक्ट्रॉन मूव कर रहे थे उसमें रेडियस उनका कंटिन्यूसली इंक्रीज होता है, हेलिकल पाथ था. वेयर एज इन ए बीटाट्रॉन द इलेक्ट्रॉन्स आर मेड टू मूव इन ए circular path but with constant radius. So this is very important part, that in Betatron these electrons, they will be moving in a path, in a circular path but with constant radius. So fixed path का circle बनाएंगे. दूसरा इसमें जो magnetic field आता है, that is average magnetic field, that is inside the orbit. And the condition is, this is very important Betatron condition which we will be driving firstly. And this condition is that the average value of the field at the center must be equal to twice the value of the magnetic field which is just used to guide the electrons in a circular path. Whereas this B average, it is a time varying field. B average will be a time varying field, and the time varying field produces changing magnetic flux, and a changing magnetic flux gives rise to induced EMF, that is some kind of voltage, and that give rise to some force on the electron, and these electrons, they will get accelerated. So here two types of magnetic fields we are using. One is just to guide the electrons in a particular path, और उस मैग्नेटिक फील्ड की जो डायरेक्शन होती है वो इलेक्ट्रॉन के पाथ के पैरेलल होती है, तो वर्क डन इज जीरो बाय दैट फील्ड. So that field is just to move the electrons in a circular path, that will give the necessary centripetal force. Whereas this B average, this will be a time varying field, and it will be giving some induced EMF which will in turn accelerate the electron. So in both cases there is no direct electric field, no electric field is applied, rather one magnetic field is used to move the electrons in a circular path, and the second magnetic field, which is time varying, is used to accelerate the electrons indirectly. And the condition is, this Betatron condition is, B average must be twice B guide. So the basic principle of this operation is that this system just acts like a transformer. In a transformer there is a primary and there is a secondary, and whenever there is some magnetic flux changes in the primary, then some induced EMF is produced in the secondary. So the same thing happens here. Here there is a time varying magnetic field, and whenever this time varying magnetic field changes, it produces some electromagnetic force which gives kinetic energy to the electrons, and these electrons, they are moving along a circular path of constant radius. So that part, that winding of the electron, that path of the electron, that acts as the secondary. So that directly the changing magnetic field at the center of the orbit produces some induced EMF which acts on the electrons which are moving in this circular path. So that's why the electrons, they get accelerated. And so these are the three Betatron conditions. Number one, the magnetic field should keep the particles in a circular orbit with constant radius. Number two, that T average, the time dependent magnetic field, it should generate accelerating electric field via induction, by induced EMF, which will be used to accelerate the electrons. And the third condition is, for stable particle motion, the magnetic field at the orbit should be 1/2 of the average field inside the orbit, or you can say average field must be twice the field at the orbit, which was the guiding field. Now, before we go to construction part, first of all, let's derive the Betatron condition. Now, this is called the equilibrium condition of the main orbit, or we are going to derive the Betatron condition. Now, suppose phi is the magnetic flux through the orbit area, and let B the magnetic field at the orbit, and let R be the radius of that path through which the electron will be moving. You know what's the relationship between induced EMF and rate of change of flux? This is the relation, that induced EMF must be equal to rate of change of magnetic flux. Now, you know by definition what is this induced EMF? Induced EMF is work done per unit charge. So what will be the total work done on electron in one revolution? That will be whatever is the value of the induced EMF multiplied by the charge, E into epsilon. So if we substitute the value of this epsilon induced EMF, we will get this work done equal to E into d phi by dt. That is charge into rate of change of magnetic flux. Now if you want to calculate what is the average tangential force, because this force acts in the same direction in which the electron moves. It changes its direction along with the electron when it moves in the circular paths. It will always be along the tangent. That's why this force is able to accelerate the electrons, because its direction is parallel to the direction in which electron moves. And this force we can calculate, work is force into distance. So force will be work divided by distance. Which work? Work done on electron in one revolution to the distance traveled by the electron in one revolution. Now work done on electron in one revolution, let it be W, that we have already calculated, and this divided by distance traveled by electron in one revolution, that is the circumference of its path, that is 2 pi r. So this value, if we substitute the value of W, we get this 3.3.9 equation, that is the force. Now we want to calculate the same force in a different way. For that, we apply this condition that whatever is the magnetic force acting on the electron, that is the guiding magnetic field. So that field gives the centripetal force. So mv square by r is equal to ev into b. Now if we solve this equation and we calculate momentum from here, then momentum p is equal to m into v, and from this equation we can get it equal to er into b. Now there is another definition of force. Force is also given by rate of change of momentum. So F is equal to dp by dt. If you substitute the value of p from here, er into b, we get this equation. So ultimately we get F is equal to E into r into dB by dt, considering r to be constant. It doesn't depend upon time. So if we compare this force with the previously calculated force given by 3.3.9 equation and 3.3.11 equation, 12 equation, we get from here d phi is equal to 2 pi r square into dB. Now if we integrate it from phi 1 to phi 2, where b changes from b1 to b2, we get this equation 3.3.13 equation. And if we assume that initial flux is 0 when b was 0 and the final flux is phi when b is equal to b guide, we can get this value of phi is equal to 2 pi r square b guide. This was the magnetic field at a distance r from the center of the magnet, which is same as the radius of the electron orbit. Now this is called Betatron equation condition. And on the other hand, we can also calculate the average value of magnetic field, because we have to correlate the two. B guide we can get from here, B guide we can get from this equation. Now we have to calculate average magnetic flux density, which is equal to total flux divided by area of the orbit. So phi divided by pi r square. So if we compare the equations 3.3.14 and 3.3.15, we can get this relation between B average and B guide, and this is very important condition, which is also called Betatron condition. Sometimes in paper you can get only just to drive what is Betatron condition. And on the same lines, we can also calculate what's the kinetic energy in the relativistic cases, because kinetic energy is equal to m naught c square c4 plus p square c square. अगर रेस्ट मास एनर्जी को इग्नोर कर दे तो kinetic energy p इंटू c के इक्वल आ जाएगी, और वहाँ से total kinetic energy E R C और B maximum के इक्वल होगी. Now we come back to the construction part. And in that construction part, we see that the most important part, this is one of the photograph of this Betatron. Now this is the central part is the donut shaped chamber. So there is the donut shaped chamber, and this diagram is taken the vertical section of the actual Betatron. So there are magnetic coils, and in the main magnet, this is the guiding field. Guiding field is uh, which is half of the B average. B average is basically twice the B guide. And then the shape of the magnetic field is taken such that these lines of forces, they are radial, and so that the force due to this magnetic field, time varying magnetic field, and which give rise to this electromotive force, and that gives rise to in turn the force which acts on the path of the electron. It's always parallel to along the tangent. So that is done by this tapered magnet, by taking the special shape of the magnet, so that we can create a proper accelerating chamber in which we are applying this magnetic field. So they should all have the proper magnetic field, and this electron gets accelerated only during the 1/4 of the alternative current cycle. Now this alternating current cycle, it is given to create time varying magnetic field. In that time varying magnetic field, only 1/4 of the cycle is used to accelerate the electrons. But during only this much time, electrons make so many revolutions in that donut shaped chamber so that it gets accelerated. Then basically we can see this diagram, that this is the donut shaped chamber, to which at the center there is average field, and at the orbit there is a guiding field which keeps the electron moving along the circular path, which this is the orbit of the electron. And here there is an electron gun, and from this part the electron is they are injected inside this path at the proper time by pre-accelerating them by some other device. And once they enter this orbit, the electrons, they go on moving along the circular path, and this average field, time varying field, only from this 0 O to A, 1/4 of the cycle, is taken to accelerate the electrons fully. And then by applying a certain condition, by disrupting that Betatron condition, we can take them out when they are properly accelerated. And the conditions and the values of the magnetic field and everything is kept in such a way that the Betatron condition is always met. So after making a number of revolutions in this donut shaped chamber, whenever we want to take the electron out, we disrupt the Betatron condition by sending some extra current or so that this condition is no longer met. Then the electron will no longer move in the path in which it is moving in a circular path of constant radius. So it will try to fall inwards, and then it is made to strike the target. So by this method we can accelerate the electrons which we could not accelerate by using cyclotrons. So this is a special device which is only for electrons, for accelerating electrons. But there are certain limitations of this device also, that electrons, because they are charged particles moving at very, very high energy, so they sometimes radiate electromagnetic energy. So there are certain losses also. And maximum energy कितनी दे सकते हैं इलेक्ट्रॉन को, वो डिपेंड करेगा कितनी स्ट्रेंथ है मैग्नेटिक फील्ड की. द स्ट्रेंथ इज लिमिटेड बाय हाउ मच size we use that of magnetic core. And because of relativistic speeds, they are attained very easily for the electrons, because being light particles, so acceleration become very difficult. But still, with the help of Betatron, up to 300 MeV we can give energy to the electron. So the maximum energy given to the electron, it will be limited whenever the energy lost becomes equal to energy gained. That means we can no longer accelerate the electrons further, so then we have to take the electron out. So this was about accelerating electrons, and next time we will be studying two more accelerators. One of them is synchrocyclotron and other are synchrotrons.